Okay. Today is October the 20th. If you look at this packet, you should be stressed out. You should be looking at it being like, oh my gosh, there's 6 pages of notes. Are you guys getting those back there? Did I run short? Now here's what you need to know. It is 6 pages of notes that we are going to work on all week. When we do notes tomorrow and when we do notes on Thursday, it's going to be these notes, so don't lose them. 3-4 is a massive lesson with a whole lot of stuff. Starts out very basic, and by the end it gets pretty challenging. And I just was unsure with the new block schedule and the day, how to make it work. So what I decided was I was just going to put all the material in one note set, and we will just get as far as we get each day. And I have the assignments such that today that we don't have to get, tonight's homework is not about this. Tonight's homework is about writing equations from words, and we did notes on that last week before break. And so you're going to have a few problems where you're going to read a word problem and write it. Based on the check-in, we need more practice. So that's what we'll do there. Then we are going to come in tomorrow and do some more of these. And then you have a 3-4 day 1 worksheet, and then we'll finish them by Friday and have 3-4 day 2 worksheet. And so by Thursday, not Friday, we'll be through all that material. Does that make sense? Okay, so today we are going to begin working with equations with variables on both sides. Now, both sides of what? Both sides of the equal or the inequality symbol. This is lesson 1-3 in your textbook. If you want to use your textbook for support, remember I showed you how to do the interactive textbook where you can see somebody do examples with you. You can also go to the PDF version if you want to see more examples worked out. So just so you know, it's 3-4 for our lesson, but it corresponds with 1-3 in your textbook. Okay, we're going to start out with a visual. I do not expect you to make a visual for every problem that you're going to be doing over the next few days. I think this really helps kids understand how this works, okay? So first thing you need to know, I should have put it on here, is that at one of these little blocks, they equal 1. Okay, so the barrels are X and the blocks are 1. And this is an example of a balanced scale that I had to use when I was in junior high science. Since then, they've got fancy, and you have those triple beam balances now, and that's a little bit different where you get to just move the weight and figure out how to balance it. But in this method, this was the fulcrum point, that's the tipping point, and that represented an equal sign. And so you would set this bar here, and it'd be 2 trays, and you'd put stuff on one tray, and then you'd put weights on the other tray to figure out what something weighed. And you could find the measurements and things like that. So what this is telling me right now is that this expression of barrels and boxes is equal to this expression of barrel and boxes. They weigh the same, okay? So who can tell me the expression for the left-hand side? What would that expression be based off those pictures, Tathag? 2x plus 5. Does everybody agree how to get that? Anybody confused on where I got that? What would be the right-hand side? Aubrey? 3x plus 1. And according to what I said, those two things are equal. Yay? Okay. First thing we need to understand is, different than previous lessons that we talked about. Let me see if I can get that down there. There we go. This wall, I never really made you draw. This wall would be between these. When we start talking about this, do you think I can collect up the barrels and count it all and say, oh, I've got 7 barrels all together, or no, 5 barrels, right? I would not collect them up because one's on one tray and one's on the other, and that would cause issues. Does that make sense? So as we start getting things with variables on both sides, the first mistake that lots of kids make, think, oh, get out my boxes and say I have 5x. Well, no, I have 2 on the left, 3 on the right. That doesn't mean I have 5 altogether because they're balancing each other out. And in fact, because there's some on each side, they're kind of canceling each other out in what they weigh. Would that make sense? That's why you would never want to say 5. I'm not a big stickler on draw the wall, but I do think the wall helps when you get to variables on both sides. So if our goal is to isolate the barrel, in this case the variable, I want to try to get one barrel all by itself on one tray and nothing else. Does everybody agree? Does everybody agree that I could kick this barrel and this barrel off, and that would get no barrels on the left? Now, if I did that, what would happen to this balancing point? Right, it would be heavy over here now because they were balancing each other out, and light over here. So how could I restore the balance? Charlie? I'm going to kick this one off, and I'm going to kick this one off. Does that make sense with everybody? So these would be gone. Now I would just have 5 singles. These would be gone, and I would have 1 barrel and 1 single. I'm trying to get the barrel by itself. So what else could I do now to help me? I hate this new update. I'm having some issues with my pen. There we go. What'd you say? Somebody said it. I missed it.
Kick out the box on the right.
Kick out this box on the right. Now I'm no longer balanced, so I would need to take one off of this side. And now I would have 1 barrel, 4 blanks. So what does that mean 1 barrel equals?
4.
X equals 4. Same as 4 equals X. Does everybody make sense? Now, I don't want to draw pictures and models and barrels and boxes to solve my answers. So let's talk about what would be a good idea for this throwing barrels off the tray mathematically. What would that represent? Would that represent adding, subtracting, multiplying, or dividing, do you think? It would represent subtracting 2 x's from one side and subtracting 2 x's from the other. Does that make sense with everybody? And then I would do that step, which I did, which left me with 5 equal to x plus 1. And then I threw off the single, which would be x minus 1, and I would end up with my x equals 4 statement. And so it really looks pretty similar to what we were doing before break, except instead of just moving numbers around like we did before break, now we're going to have numbers to move around and letters to move around. And that is all we're doing all week long. Variables on both sides. The equations are going to get harder and more complex. But at the end of the day, your number one goal is to isolate, get 1x all by itself. Okay? So the key concept for today, you've got 3 bullet points. You're going to write the first bullet point in. The last 2, we're just going to highlight some things on. The key concept is all your variable terms must move. All variable terms must move to one side, and all constants must move to the other. Now notice what it doesn't say. It does not say you have to move all the variable terms to the left, or you have to move all the variable terms to the right, or you have to move all the numbers, or whatever. It says you got to move everything with a variable one side and everything without a variable to to the other, and it doesn't matter which side. And this is probably the most challenging thing about this lesson is that there are like 5, 6, 7 different ways you can start a problem. And all of them are fine, all of them are legal, all of them will get you the right answer. I know you love that, sorry. The one thing I will say that is required for this class, for my room, is that when you are doing this, the variable terms must happen first. That has to happen first. So when you start every problem, you're going to take care of the variables, then the constants. That makes the problem look normal. If you do the numbers first, it doesn't make the problem look normal, and then people get confused because they're like, this looks different. By taking care of the variables first, you create a 1 to 2 step equation. Okay? How are we going to move items? Because that's the next thing we want to make sure we understand. It says we have to move. We move things with inverse operations. And so inverse operations means when you see a positive term, you're going to subtract. And when you see a negative term, you're going to add. We are not going to be doing multiplying and dividing on the moving step. You do the multiplying and dividing when you're trying to separate, when you're trying to isolate. But for now, we're just moving them around. Okay? Once you do this, you'll be at a 1 or 2 step equation. Main thing you want to understand is we're going to use inverse operations to get variables on the same side. If you get the variables on the same side, then you have a problem like we did before we went on fall break. So all we're doing today is learning how to make it look like something you're used to. If we can make it look like something you're used to, is everybody ready? Everybody got a copy? Did everybody put the little extra notes on the notes that I gave you? Let's try one together. Number 1. 10x minus 3, not 10x, 10 minus 3x equals 2x. You have options. You can move the negative 3x to the right, or you can move the positive 2x to the left. Your choice. There is definitely one move that makes it easier than the other. Anybody got any ideas which move is best?
Moving the negative 3 to the other side.
Right. So first of all, does everybody understand we're not going to say we have negative x?
Yes.
We don't collect them because they're on opposite sides. He thinks moving the negative 3, and how would you move the negative 3, Ryan?
I would get rid of the I would add 3x to the other side.
I'm going to add it to both sides. I'm going to add it here so that cancels out. And what I do to one side, I have to do to the other. That's going to give me 5x equals 10. Does that look like an equation we've been able to solve already? We did that in Bell Work the very first day, like back in 5th grade. Divide both sides by 5. What's x equal? 2. Now, that is a much easier move. I'm going to write over this one and show you, like, if you had decided to say minus 2x, then you would have had a 0 over here. So you would have had 10 minus 5x equals 0. Lots of kids forget that. Then you have to minus 10. So much more work to do it that way. Okay, so I'm not going to do that. I'm going to make it as least work as possible. When I get to number 2, it doesn't matter which one you do. There's no one that makes it easier to do one way or the other. So you get a pick. You can move the x to the right or the negative 5x to the left, and it's totally your choice. Here's the one thing I always do. If possible, it's not always possible. If possible, I try to keep my x's positive. You guys stink at negatives. Number 1 errors are people forgetting negatives, dropping negatives, ignoring negatives. So I try to make negatives not happen. Is there any move that will eliminate negatives in this problem? Negatives in my next layer.
Adding 5x to the x in the
Does everybody feel like if I add 5 here and I add 5 over here, then I'm going to get a positive value?
Yeah.
And that makes things a lot easier. I can take away this x, but then that x is going to be negative. It won't change my answer as long as I do all the math right, but we got to avoid those little careless errors. I'm going to start with plus 5x. Does that make it sense with everybody? That's going to leave me with 6x plus 6 equals 18. Yay or nay? Now we got a basic 2-step equation that everybody should feel pretty confident in solving. Subtract 6 from both sides. 6x equals 12. Divide both sides by 6. X equals 2. Yay or nay? Making sense? Try number 3 by yourself right now. Try number 3 by yourself right now. Turn the page. I'm always going to start with my little wall there to help me keep things straight. How many of you moved the 4s? That's good. How many of you moved the negative 5s? So that means you're listening. I'm going to start with plus 5s. Does everybody follow why? That's going to leave me with 9s minus 12 is 51. Now, if you did the minus 4s, you'd still get the right answer. You just have a lot more negatives floating around. Adding 12 to both sides, yes. 9s equals 63 divided both sides by 9. S equals 7. Try 4. 4 tends to stress people out a little bit. This is where kids who are kind of been following the pattern get freaked out because they're like, neither one's negative. What do I do? They don't have to be negative. You just want to make a move that will keep the variables positive. The inverse move that will keep my leftovers positive. So I can move 4 in or I can move 12 in. Which move is going to keep my variables positive? What do you think? Moving the 4 or moving the 12? Moving the 4. I'm going to start with minus 4n. It's very important that your work looks like mine where you're showing what you're doing each step. Your brain needs to see that. You got to stop thinking I can do these in my head. This is easy. I'm not saying it's not easy, but you need to let your brain process what you're doing because the equations are going to get more and more challenging. And you're not going to be able to just look at it and know. I can't just look at that and know what the answer is. Now here you got to be careful. What do I get when I subtract 4n? When I subtract it on the left, what's left? Negative 70. Don't put 70. That causes lots of problems. Don't drop negatives. Does everybody understand why it's negative 70? Somebody said 0. This is 0. Yes. 0 minus 70 equals 8n plus 2. I'm going to subtract 2 from both sides. Yay. And that gives me negative 72 equals 8n. You're going to get negative answers. Don't stress. It's just a matter of trying to keep negatives out of the problem. I'm going to divide by 8 on both sides and get negative 9 equals n. Yay or nay? All right, you try number 5 for me right now. Does it make a difference that there's an inequality symbol in that one? because there's an inequality does not mean it's a big deal. I hope you all started with plus 5x. Would adding or subtracting terms ever flip my sign? Only multiply and divide flips your sign. Do we agree? 7x plus 15 is less than or equal to 43. Don't write equal. It's a whole different problem. We're doing this one still, boys. Let's focus up here. We're going over number 5 right now. What's the matter, Ryan? We're doing 5 right now on our notes. Number 5 in our notes. That's the worksheet that I'm going to talk about in just a minute. We're still working on the blue paper. Number 5. Everybody on number 5. Subtract 15. When I subtract 15, I get 7x is less than or equal to 28. Divide by 7. X is less than or equal to 4. Okay? That is enough for today. We'll pick up tomorrow right where we're at. Today's assignment I just gave you is assignment number 26. Put a 26 at the top. It's 1 through 11. Please look at it now. For each problem, you have 3 things to do. And notice how I want you to do it. I have given you 3 models of exactly what I want you to do. Number 1, I want you to define your variable. Everybody look at number 1 with me. It's a word problem about a number. It says number 1, I define my variable. We're looking at number 1 right on your paper. Don't leave yet. Does everybody see where I'm talking about define your variable? And number 2, you're going to write the equation for the words. And then number 3, you're going to actually solve your equation. Notice I've modeled 3 problems for you of the 11. So how many does that mean you got to do? 8. I need your 8 to look just like these 3 models. Here's my variable. Here's my equation or inequality. Here's my word. Got it? Hey, I don't know if you'll be able to turn this in tonight. Canvas is like broken. Take a picture of it so maybe we can print it tomorrow. Maybe I'll have you hand it in tomorrow. I don't know. We'll see what happens tomorrow. Great job today.